frame, and then we take that generated frame and use it as context for attention for the second frame. So instead of using the ground truth as before, we use the actual generated frame during the training. So we kind of unroll the inference during training, etc., etc. For the third frame, we use the first 2 frames in a similar manner, and in this way, we kind of simulate what's happening during inference. And in the spatial domain, again, we're doing denoising, going from this dark green color, which is very noisy, to less noisy for every frame. And then we take the final tokens. These small squares are tokens, actually, in the DIP architecture. Take the final tokens and use them as KB caching for the next frame that we denoise again. Again, something similar to what you see on the left, just on the spatial domain. So, very simple idea, basically mimic the inference during training, and that basically fixes the distribution mismatch, and then it's finally correct to apply a technique like DMG as the distribution matching loss. And actually we tried other distribution matching losses, including again, which is a sort of distribution matching done by the adversarial loss, and SID, another technique, score identity distillation, and they all work because again, it's the right thing to do once you fix the mismatch. In terms of quality, comparing to COSV, the previous project, we get much better kind of both visual quality and more correct motions. We got rid of the flickering, we got rid of the oversaturation, and users basically agree with these observations. They prefer the self-forcing results over COSV. If we compare to the teacher model, the bidirectional one that we started from, in this case the one 2.1, we actually get slightly better quality, which is not surprising. Some, many distillation actually methods report a slightly better performance than the teacher one, because you can apply different losses in different ways, and you're more flexible basically. And we got the same observation here, while being much, much faster. So 150 times lower latency and 20 times higher throughput, in this case 17 frames per second, so we're really getting to real-time generation. If we compare to other autoregressive methods out there, again, we are kind of much, much faster, as you can see on the left, in terms of latency and throughput, and surprisingly, even for larger models like the MAGI-1, we get better quality based on user studies. You might think that this kind of mimicking or unrolling that we're doing during training is very slow, but actually it's not that slow. We still process a lot of tokens in parallel, so there's a lot of parallelism left to be exploited, and the overall method is not slower than the COSV, for example, which is the diffusion forcing you can see on the left in gray color. And there's another trick described in the paper, some gradient stopping that we do to, again, avoid excessive runtime during training. In terms of kind of robustness, this method, well, first, all kind of distillation methods, if you train them too long, they start to you start to see degradation of quality, and it's including the self-forcing one, but it happens much, much later. So you see the curve on the right goes much higher because it's higher quality, and degradation will happen much later. So it's a more robust method, or much more robust, because again we fixed the core problem of distribution mismatch. So the last project I'll mention, which is another step towards real-time generation, has to do with kind of the inherent slowdown that you have for generating videos that are longer and longer. So basically, to generate the current frame, it takes more and more time the longer your context is, and that's the nature of transformers. Basically things grow linearly for every frame, depending on as a function of the video length. And there is this kind of family of techniques called state space models that has been developed in the past few years, including, probably you're familiar with Mamba and Mamba 2 and others, that basically address this problem by achieving basically a constant per frame speed generation for every frame by using this kind of state space technique. And that's what kind of, that's the core concept that we introduced into causal video generation in this project that we called SSM World Models, with Paul Ryan, a student from Stanford that interned with us last year, and my collaborators from Adobe, Yotam Litzan, Richard Jang, and Shun Wang again, as well as Berlin Chen and Tri Dao from Princeton, and POS advisor Gordon Waitstein from Stanford. And this project we just released on Archive as well. And the concept here is very simple. Basically, we introduce a blockwise SSM module into the basic transformer layer, as well as a frame local attention. So how does the blockwise SSM work? Basically, the traditional way is you have this kind of scanline order between the tokens within the frame, and then you move to the next frame for the next tokens. And if you apply the SSM idea that way, kind of scan-wise order within a frame and then temporally, then the results are not very good, because even SSMs have kind of an effective limited memory. And if you waste kind of this memory on all the tokens within a frame and only then go to the next frame, you kind of don't gain much in terms of the temporal memory or the extent. In this project we found kind of, and there's the other extreme of applying the SSM only temporally, kind of only take a token in some corner of the image and move only the temporal domain, and only then move to the neighboring token. We tried that kind of variant, and that was also suboptimal, because you lose kind of spatial coherency between the neighboring tokens. So we found this kind of middle ground that worked best, which is applying this SSM in a blockwise manner, so within a small spatial block, and then temporally, and then you gain a lot of kind of temporal memory and enough spatial coherency. And then you have the traditional kind of local attention that applies regular attention between tokens within the frame and nearby k-frames, which is still needed to get good kind of short-term temporal coherence and spatial coherence. So these are the kind of the two main changes, and it's pretty simple, but it's very effective. So in this case, the student kind of worked from Stanford, so compute was a little bit limited. So all the results are applied on this kind of toy world, but I believe this could really work on high quality videos as well. Basically, what we show here is if you move the camera to some other rooms, some other viewpoints, and then move back, what happens with traditional kind of causal transformers, like cosvid and self-forcing, is that you get a change in appearance, because the memory is limited, and it tends to forget, and you change basically what you see. So it deviates from the physical world. And in hybrid SSM, you get much closer kind of look if you go back to the original frame. We also applied it to a slightly more interesting Minecraft dataset, and again, some results are in the paper with numbers, and the results are also very good in terms of memory. If we quantify kind of this better temporal memory, we see with the gray curve here denotes the regular causal full context, which is extremely slow but the highest quality, because all frames can attend to all other frames in a regular transformer way. And the orange curve represents our SSM result, which is close to causal, but still kind of maintains, but it's much faster. And if you apply kind of Mamba 2 naively, with or without frame local attention, you get a very rapid drop because of this raster scanline order, the traditional order in which Mamba is applied. And as I said, that's not good in terms of preserving the long-term memory. That's it. These are kind of the three small steps in this, I believe, very important step of interactive video generation that will open the door to a lot of new kind of control, new possibilities, and that's the future of video generation. Thank you very much.
Okay, so maybe we can have one quick question. We are a little bit over time. Yes, John.
Hey, great talk. Thank you so much for that. Can you give us some intuition as to like what sort of things get lost between batch video to autoregressive video? Like, my instinct is that like something gets lost. It's probably like diversity maybe or some quality issues, but I don't really have a good sense of it. It feels like it should be like an intrinsic thing.
Yes, by definition the quality will be lower because you cannot see the future. So by definition, and that's kind of the whole trick. How do you maintain the quality as much as possible closer to the bidirectional kind of video, because that's the upper bound in terms of quality. That's why we, the DMD loss, we're trying to mimic the teacher, because by definition you're going to lose quality, and if the DMD assumption is not correct, then you're not applying the right loss. And, but the whole story is about how do you maintain the quality if you could see the future.
Yeah. But what do you lose, like intuitively, in terms of like what the results look like?
The quality, all kinds of artifacts. You're probably familiar. Some blurriness, loss of detail, colors change a little bit. That's it. Flickering again. If you have some problems, that's the first thing that you start losing, basically.
It's interesting you're not losing. I would expect you to lose something like very qualitatively or causal, like something that feels like time-oriented, but it sounds like it's more just like quality on the whole.
No, you're right. Also, sorry, I forgot, and I showed it in one of the examples, bad motions. You start to see things moving very slowly, or kind of people walking in place, and things like that are related to motion. Yeah, you're right. It's not only appearance, it's also bad motions.
Thanks.
Thank you for the presentation. It was great. Okay, so let's switch to the roundtable discussion. We will have then Goldman, Misra, Ming-Hsuan and Krishna. I can. Please feel free to come. Yeah, so in this roundtable discussion, I'm going to ask you some questions, and feel free to answer it in a way. Maybe we can go it in an ordered way from starting here from the first question, and for the next one, we can start the order from there. So maybe we shall begin. So I would like to first ask a brief self-introduction for yourselves and why you are working on generative AI. Can you share your personal or professional journey creating these tools? What first drew you to them, and how have they shaped your perspective on the field? So maybe we can start with Krishna.
Yeah, so hi everyone, so I'm Krishna, so I'm currently a scientist at Adobe Research, and I have been working a lot on image and video generation and editing. Like one of the main projects I worked on at Adobe was Generative Media, and I was the co-researcher for the first version of that model. Recently, I've been working a lot on unified models for generation and editing workflow. And regarding my journey in the generative AI, basically I started from understanding background. So basically, if you see the initial part of my PhD, I was working more on around detection, segmentation, those kind of work. And the reason I started doing generation was to do better understanding. So my research, my focus was how to do better fine-grained object understanding. And I thought, if I can generate fine-grained, objects, so I will learn better features, basically for understanding. But once I start seeing the output I'm getting from generation, it started to make me, much more excited about it. And I thought that generation is the ultimate form of understanding, because if you can generate something, then you truly understand those things. And from that's from a scientific point of view, but also while working at Adobe, I can see how the research and tools we make, helps the creators to create the contents and help their workflow. So that's the most exciting part of it. Yeah.
Good, that sounds great. What about you?
Hi. Thank you. Hi, my name is Ming-Hsuan. I work at UC Marseille and Google DeepMind. I started working on generative AI for media is because the work at Google. So we work on video first foundation model. That last year we presented 2 papers, one on understanding and the other one on generation. So that's about it. Thank you.
Okay, Ishan.
Hi, my name is Ishan. I work at Meta on video innovation. I actually did not work in generation at all, and I had not trained a single GAN or any generative model up until 2023. And so what changed my perspective on this was I worked a lot on representation learning, and a lot of self-supervised representation learning is basically setting up a prediction framework where you hide certain parts of the data and try to predict something from something else. And essentially looking at the rise of like multimodal diffusion models where you didn't observe a lot of node collapse sort of changed my perspective on what could actually be possible by training these models. And so I also view basically a lot of these generative models as learning a lot more than what the supervision is being provided to them, because text to video models, for example, you don't describe every single thing happening on every single pixel. And even if you don't do that, the model actually learns how to model a lot of the nuances about the world automatically by actually being trained. So that's one of the things that like really excites me about this quite a bit.
I'm Dan Goldman from Lucasfilm and Industrial Light and Magic. And if you were here 20 minutes ago, you heard me telling my career story, but I'll recap a bit of it. I started in computer graphics, working in visual effects production, and then during the course of my PhD, I got more interested in computer vision. When I went to Adobe Research, I worked very closely with Ellie, who just gave her last talk, did a lot more computer vision and started to get into machine learning. And then moving to Google to do more machine learning, I became interested in generative models. And so now it's like full circle, everything's coming together, and all of these things are becoming one gigantic, complicated field. But I would say like what excites me is not so much, I mean, obviously there's technical and research elements and all of that interest me, but I think actually what's most exciting about this particular moment in the field is the accessibility of it all, and that you have like, senior researchers contributing the same as like people who are just picking this stuff up for the first time. The accessibility of these tools and the open source community makes it such a fun playground to, anyone can really get started with, I mean, you have to have GPU resources, but beyond that, like it's very approachable, and a lot of people are contributing that may not have traditionally been able to contribute to this work in the past. So that's been
Okay, thank you for sharing your experiences. I think these are really interesting. Let's switch to our next question, which is about gaps and the innovation needs. So where do you see clear gaps that current generative models can't address, places where we need new methodologies? And conversely, where might existing approaches be sufficient if we focus on scaling and just build strong application layers? So we can just continue with them and come from that over.
Yeah, I mean, I think my talk was actually about this topic, but I'll go into a little bit more pontification on it. One of the things that I was frustrated with at Google is that I was always on to the next foundational model, and there were not enough people working and thinking about application layers. I think that's changing now. I definitely see like flow from Google and the VO2 features and stuff. Things like image editing from Meta. There's certainly more attention being paid to application layers and control, but it still seems like a bit of an afterthought. So I would love it if people just spent more time thinking about really human-computer interaction aspects of these kinds of models.
So can you give a little bit like specific examples of how human-computer interaction can be enabled?
I mean, I think it comes from interaction with practitioners. You see how they work and how they want to. I mean, a very simple example is when a creative person is whether it be a painter or an artist, or a photographer working in the studio, you're looking at something like, I want to change this one thing, but I don't want to change other things. Mm-hmm. And it's easy enough to prompt a model to say, change these things. It's very difficult to say, don't change these things. So I think that's just sort of a meta comment on the state of control paradigms, but I think you can go deep in lots of different instances of that. What does it mean to not change the colors? What does it mean to not change the motions, but still change other things? So that's, control net is a great example of starting to move in that direction, be able to keep some things fixed, but if it starts to break down when there's multiple multiple control nets applied at the same time, does it scale well? I've seen some more recent research that tries to come up with sort of multi-control approaches, but I haven't seen what looks like a unified framework.
What do you think, Sean?
Yeah, so I agree with everything Dan said. I think the two sort of problems that stand out to me for current generation of models is the input to output alignment, so similar to what we were talking about in terms of editing. I think the amount of control you can provide and the amount of instruction following the models can do strongly needs to improve from where it is today for them to be more broadly usable. I think that's one area of focus. The second one, which I think is more from a scientific perspective, is we've always talked about these video generation models as being world models or like trying to use them as simulators, but I haven't seen, I think a lot of progress needs to be made to figure out, like you go from the input to the output, but then how do you actually like use any signal back from the generation to improve the input back? I think that like closing that loop is probably something that's like fundamentally missing from whatever we do.
Yeah, follow up the discussion. So yeah, I think there are two things that I would come to my mind. One is about unified model for understanding and generation. So right now there are some effort on that, but I think more work needs to be done rather than just simply spit out some result and that's it. And you can take some iteration just to understand what you generate and then revise and all that. That's one thing. And the other one is also about unification, about tokenizer. So in the last project we worked on VFF, Video First Foundation Model, where we have to use two different kind of tokenizer, one for generation, the other one for understanding. We could not use the same one, but I also seen that there are some recent people trying to unify, just use one kind of tokenizer for both understanding and generation. And other than that, the other thing is John Barrett is here, for 3D stuff, I think adding more 3D or synthesis stuff would be good.
Yeah, I completely agree with all the points discussed, and for me also, one of the biggest unsolved problems is the identity preservation, because for a lot of these edits, like a lot of time, when you generate something, you have 70-80% there. It just doesn't like certain parts of it, and you want to edit over it. And a lot of times, current editing models don't give that control yet. And the most tricky part for the editing is that it's very hard to get training data. Like for example, for text to video, text to image, it's easy to obtain. But for editing, you just want to change color of the shirt. Like how to get such real pairs? Like you can go and shoot such like images and videos, but that's gonna take forever. So you usually rely on existing models, which kind of are the inference-based methods and all, and do very heavy filtering to get high-quality pairs. So focusing more how to create such training data and focus on identity preservation will be the main thing, because we're gonna have very decent, base model, foundation model, but these downstream tasks are equally important, and we need to spend, enough time to create right training data and also approaches to solve that. Yeah.
Do you think, like, if we just find a suitable data set and scale it up, do you think the identity preservation problem can be solved, or do we need external, approaches or methodological innovations to overcome them?
So I think, as I mentioned, because it's not so easy to get the data itself, so you have to come with the new approaches, focusing on those kind of edits, basically, to get, and use other modalities. Maybe video is a good source of getting image editing players, or like other way around, so just think how other modalities can provide you, training data for, some other missing modality for which is hard to obtain.
Yeah, so my next question is actually related to your answers. So it's about unified versus domain-specific models. So what do you see as the future of media generative models? Are we moving toward one unified foundational model which wins everything, or will domain-specific specialized models continue to play a crucial role across these fields? So maybe we can start from yeah. It's changed to
Alright, so I think both will continue to exist. I don't think it's like one model sort of like delineates the for the second one. This is some lesson that we've learned also from other fields, where it's not just about generative models. I think you need strong foundation models, but at the same time, you also need strong domain-specific models, because there are the needs for both of them and the requirements for both of them are quite different a lot of times. So I don't necessarily see them as being antagonistic to each other. In fact, a lot of the times, the strong sort of foundational models help create better like domain-specific models, and vice versa. The strong domain-specific models end up sort of creating, like Krishna was saying, a lot of high-quality training data which helps you in turn create a foundational model. So I would say it's almost like a self-feeding loop, but not really antagonistic to each other.
Yeah.
I was just going to say, I think my priors on this have changed over the last year. I think I was very skeptical that you could inject image and video understanding at a very significant level into language models, but I'm seeing evidence to the contrary now. And certainly the world knowledge that they have is critical to improving the next generation of video generation models. Like there's a lot of things that these models, and I'm sorry to anthropomorphize, I know it's a no-no, but I don't know how else to quickly say it, is like these models know a lot about the real world, and more than the video models do. So, when you want to, like, I gave this example of like when a robot gets destroyed, it should stay destroyed, right? A language model understands temporal sequence in that way. A lot of video models today don't, and so I think it's going to be key to sort of co-train these or train these in loops and synthetic data from one to the other to be able to get that kind of understanding. But I am still a little skeptical that there's going to be like one model to rule them all that does everything from language to video generation to 3D generation. That still seems a little science fiction-y, but I guess I shouldn't believe that.
Yeah, I think the main advantage of such unified model is the generalization, basically, because when you have this specialist model, you always train for specific modality, specific tasks. And you can imagine, like the amount of combination possible for both input and output going to increase exponentially. And we can't keep on training newer models for all the possibilities out there. So the good thing about this unified model is that a lot of these properties will emerge out of it, even though you haven't trained. It may not be the best model, for training for that task, but 80-90% there, and then you can always fine tune. And again, as Ishan mentioned, the main advantage of still this specialist model would be to create training data to fit in this unified model, so that it becomes better and better and try to reach the quality of the specialist model out there.
Yeah, I guess that's the core question, right? It's like surely there could be a generative model that does all these modalities at some level, but it feels to me that a custom design model for a particular modality is always going to outperform a general purpose model. On the other hand, we see amazing generalities when you do get these things together, so it is hard to say.
Ming-Hsuan?
Well, I think they cover enough.
Yeah, so my next question is about era of experience. So Richard Sutton recently wrote about an era of experience, basically where he says that agents learn through interaction, not just the static data. So what could this mean for generative video models? Like what kind of opportunities or methodologies could we see in the future? Could experience-driven learning unblock the capabilities beyond today's data-trained models? Maybe we can start with Ming-Hsuan with this question.
Probably the best way to answer this question. Yeah, but yeah, I think so. Yeah, so you see, there are more work on agent-based stuff to maybe self-fulfilling task or whatever, and then, but it makes some sense. I mean, you can never label everything, right? So you do need to have at least some data engine to help out to generate some more data and self-fulfilling purpose and several iteration. It certainly helps, but exactly how to go about with agents, I don't know for sure. But there are some more paper on that, different area on segmentation and tracking. I'm sure they will apply that to generation too.
I guess I have a question to throw back at you, which is when you talk about learning through interaction, I think there's two obvious things that you could mean. One is robotic interaction, interacting with the real world. The other would be synthetic interaction, interacting with the game world. Interacting with a game world, typically you can have a lot of different types of appearance. You typically have very limited types of interactions that are coded into the game engine. In contrast, interacting with the real world, you have real world physics, which is really complex, and you can see arbitrarily complex physical effects just by turning around in one room. But you're limited to one room, or however many rooms you can put your robot image is still pretty small. So I guess the question is like, how do you break out of one of those two modalities to get the true richness of, of the real world in your training data? That seems to be a limiting factor to learning from interactions.
Yeah, one point I would like to add here is that if you see a lot of training data we have right now is very web-driven. Whatever data you find on the web, that's what your model is overfitting to it. And there's much more diverse data in the real world which we never capture. So I remember during my master, when I was a CMU, I have this project called Krishna and my job was, like, Google Glass was new that time, so it was cool during that time, and I was wearing that for 6 months and recording my life. And it was a figure out.
That was never cool.
And the goal was to figure out what's new, and what you have already seen. And if you have already seen something, you don't need to record it because it's boring, mundane. But if something new, you want to record it. And what I found that, of course, graduate life is boring, so it's hard to find something new, but there's always some new pieces which you're never going to find on internet. So the way I look at the interaction is that it's kind of filling the gap what we're not getting out there, and getting such kind of training data, some outlier out there, and capture that for your own training.
One more thing, I think interaction, especially if you, coming back to the question of like using generation models, video generation models themselves is essentially like the word or the test bed to go interactive. They can also help a lot, like to what you were saying, like if a robot is destroyed, the robot should stay destroyed. Or when like things move, what are the exact ways in which they move. A lot of this knowledge is codified basically in pixel spaces for a lot of these things, like how do you exactly move, what the trajectories are. It's not codified, for example, in text space. You don't write down exactly how basically if somebody is like putting their foot down versus not. I think there's a lot more that you can learn by basically coupling these things together, where you can codify a lot of the knowledge into the text tokens and codify back a lot of the text token knowledge into the pixel space. And so I think that interaction is something which I strongly believe should happen, because you can't necessarily go label everything out to what you were saying, but at the same time you know that a lot of this knowledge is already present in these models, so you can basically codify that back into one space and then codify into the other space. And right now they just live in separate spaces.
Yeah, that makes sense. So let's switch to our last question of multimodality. So could multimodal generative systems lead to more contextually aware models that better understand coherence in creative works like films? So what do you think?
Yeah, I think someone, here we have someone from Runway. I want to ask some comments to them. If you will, that's okay with you?
Sure.
All right. Shechtman, would you like to comment on that? Shechtman is with Runway, so he has done the groundwork generation, so he will be able to comment.
Yeah. You can make it.
You can take my feather.
Yeah.
Don't drop it.
Just a quick comments on the film. One angle I'm very interested is the emotion part of it. And somehow, whatever model we're looking at right now, either it's a large language model or a LLM, or video model, audio model, they are all kind of different pieces, right? Different models. But to see whether there's some emotion tie, they can glue them together. So for example, if you really want to have a character in the film, all the behaviors, whether it's a voice, visual, your mental states, and the word is spoken, should be all connected with one thing that's built into identity. So that's the very emotional things. People sometimes are not really rational, and then people like to interact with someone that's very emotional. It's a lot of fun, and for film, it's very critical. I think that would be my angle to look at this. Each has a missing piece.
Thank you.
I think I'm not sure I'm going to answer the question, but I'm going to bring up just the difficulty of the problem, because I think, like I showed in my presentation, I showed a sequence, I think maybe 30, 40 shots, where things have to happen in a particular spatial arrangement. So 3D is important. Things change over time, so temporal understanding is important. But that's just one sequence. Now you think about 2,000 shots across an entire movie, or maybe it's a trilogy of movies. or maybe it's 47 Marvel movies over the last 2 decades. And of course, the continuity isn't perfect, but there are people who care very passionately that oh, this character got this scar in this movie. That scar still has to be there in the next 3 movies. But then there's a prequel, and he shouldn't have the scar. And so we think about continuity and context on that very large time scale that I'm sure people designing generative video models today are not even contemplating. So I don't know. Just it's a harder problem than you might think. That's all I want to say.
Maybe as the last question, we can have a question from audience if somebody wants to ask a question. Volunteer. Okay, then we can end. Okay, thank you for joining the discussion. It was great.
Thank you for organizing.
So now we will continue with the industry session, and our first demo presentation will be from fal.ai on generative media in the industry. How big is the wave? So, Jonathan, please take the stage.
Okay, great. All right, thanks everyone. I'm Jonathan Fischoff. I'm the head of ML at FAL. Just curious, how many people here know what FAL is? Great compliance, and good job, raise your hands. All right, so I'll explain what FAL is. So at FAL, we're an inference provider, and we also have a marketplace of APIs. So we're really interested in what is happening in generative AI, because we're always trying to get the latest open source models, put them up as fast as possible, optimize them, and provide APIs for basically every model we possibly can in the space. So we've been really lucky. We've been riding this generative AI wave that when we look back, we feel like it really started with DALL-E 2. When DALL-E 2 came out, that was the first moment where you could take generative AI and start to see how you could use it in production, in ads, in whatever. It wasn't totally there yet, but it was obvious that we're getting really close. And very quickly after DALL-E came out, there was just huge, massive progress, right? DALL-E came out, quickly thereafter we had massive improvements in Midjourney, then open source was able to catch up with Stable Diffusion, and open source has just taken off to where we are now with Flux, where it's pretty much, give or take, at the same level as a lot of closed source models. Although Google's done a good job with their latest models. So one of the things that's been happening is as all these models come out with increased capabilities, is we're seeing the cost of creation going to zero. So where it used to take huge teams to produce a lot of this art, you now have like single people that are able to just prompt and get very close to what would have taken something that might have been thousands of dollars before. And this is just going to continue. And with each model that's coming out, it's getting better. You can see that with VO3. With VO3 right now, you can just very quickly put out ads, get them on TikTok, have them go viral, without having to hire like a large production team for something similar. So when we look into the future, we just see this process continuing to the point where just the majority of all content that's being pushed out is going to use generative AI for its creation. So if you look at what's been happening just in the content creation space over the last few decades, you can just see how software is really taking over. And so this is one chart that's just sort of showing, you can see how Spotify, TikTok, Netflix, YouTube are starting to just dominate traditional media. But what's also not here is just what's happening in the video game space, which video games just together, I think, produce more revenue than movies, TV, and audio combined. So increasingly, the software generation process, whether it's for generative stuff or just through the new players, they've been taking over existing media, and they are well positioned to push out generative media that's going to push this process even further. And we can see that with Google and YouTube and TikTok as well. So what's going to happen? Well, one big change that we see is that ads, which are already meant to be targeted, they're already being targeted, when you're on your various social media sites, they're going to get hyper-personalized, right? The content is going to be able to be generated just for this person, but it's also going to be this very rich experience because you're going to have personalized videos that just for your particular, niche or whatever that happens to be. But we're also going to see something else interesting happen where right now there are a lot of ads that are native in our media that we don't really notice. This is the product placement, the cars, the various phones that people are using. We're right at the precipice where it's very easy to, after the fact, replace those products with whoever's the highest bidder at that time. So you're going to see a much more efficient marketplace for product placement. This is actually an example of some personalized ads that we did. We worked together with an ad agency that did the promos for Civil War. And so in this case, you could go to the site, it would use your photo, and it would generate a Civil War style little animated person here. So that's just one way to kind of engage users, and I think we're going to see more of this stuff. I mean, you can just imagine, we kind of missed the boat with it, but when Minecraft came out, it had a particular style, and easily being able to Minecraft yourself, you Ghibli yourself. So all that stuff's going to start happening more and more. Another thing that's happening that we're seeing with some of our customers is just the use of generative AI in e-commerce. So e-commerce is obviously taken over, but there's still a lot of in-person commerce that that we do in real stores. But increasingly, generative AI is helping to sell products that were difficult to sell before. So one example of that we're seeing a lot of is with virtual try-on. So this is something that these companies like Doji, which is a company we work with, they're just taking off. It's just an incredibly easy thing with the current technology to help sell clothes, which in the past has been kind of a difficult segment for people to purchase online because you don't know what it's going to look like until you get it. But now, using these personalized generative AI approaches, you can see what your clothes are going to look like before you get it. So a huge improvement in the user experience there. All right, so what's next? So this is from the Sora launch, and I don't know if you guys remember how exciting this was when we first saw it, but it just looks normal now, but at the time, this was a big deal. It was crazy that we could do this, and it still is crazy, and video continues to be a huge growth area for FAL, and we just expect it to keep growing. We're seeing that with VO3. We're nowhere close to the end of the video wave. That's really just taking off right now. So video models, they're super expensive. You can see You know, we're estimating they're 20% more compute intensive. I don't think those numbers are necessarily going to match reality with something like VO3 with its audio generation as well, but still very expensive. But they're incredibly more engaging, right? And you know, if you make a video ad or you have a static ad, the video ad is going to get seen more. People are going to interact with it more. So we see the video market as being 100 to 250 times as big as the current generative AI market. Yeah, and so speaking of VO3, you know, not only are we able to generate video now, we're generating audio as well at the same time. We're going to see, you know, things go the other way, where you know you give it audio, it will generate video to match it. All this stuff is happening quite rapidly. We made a quick little video with VO3 to show off how exciting this was.
Scream in his face, you piece of horse shit! We've been holding back the things we've wanted to say for a long time.
I hate you!
I love you. All that time, your foam art can't fix your personality.
I just want to stay home and play video games. It is good to say what you want, even in AI videos.
Say whatever you want with VO3.
Awesome. Yeah, so that was all made with VO3, and it's just been very impressive to watch what people are doing with that, and we expect more of that. So faster, cheaper video generation is coming. I mean, we saw it in the cause video, in the self-forcing talk. I mean, we're not there yet, but we're, you know, the industry continues to work on it. One day, hopefully, we'll be able to get to the point of, you know, just being able to real-time stream the video back. It's a lot of the things that we've actually already seen in previous talks that we sort of see are coming. You know, the world engines, and just being able to do sort of choose your own adventure type stories. These are all the types of new use cases that a lot of this technology is going to unlock, and it's going to be really incredible just to see what people are able to do with this as it gets cheaper. Right now, it's still prohibitively expensive, but even that being the case, it's being used an incredible amount. So, what about image models? Are we done with image models? No, obviously not. I mean, and we actually just talked about it in the roundtable conversation. You know, even though image models are being used a lot, they're still missing a lot of the control and, you know, the artist workflows that people want. So there just continues to be, you know, more progress in that, but we're not there yet. You know, we're not really able to get the coarse to fine-grained workflow that people want and be able to kind of change small things without affecting everything. But we are getting a lot closer, and I feel like nothing is stopping us from getting there. So that's kind of what we see at FAL. You know, just we're at the beginning of the video wave, and really just rounding out the image experience so that, you know, the content creators can really do what they want. But it's all very exciting, and definitely come talk to us. We are hiring all the time, hiring even more now. If any of this stuff sounds exciting, if you want to work on video models, fine-tuning video models, we're not training foundational video models, but we will fine-tune them. And same with any of the image models, and then any inference optimization. We're always looking for people that can make inference run faster. So definitely come talk to me if any of this interests you. Thanks.
Okay, thank you, fal.ai, for your presentation. Now we have another industry presentation from Abaka, and it will be on frontiers of generative AI and datasets.
Hi everyone, it's a real pleasure to be here at CVPR and to sponsor and support the CVEU workshop. We believe this is an exciting space where vision meets creativity and also computation. And also, hope you guys enjoy the hot chicken so far. All right, something about myself. I'm Yunfei, CEO of Abaka AI, and I'd like to take a few minutes to briefly introduce who we are, what we do, and how we are helping push the boundaries of generative visual systems, especially through data. And here is a fun fact about our company name, Abaka AI. So it starts with both the letter A and B, which means we always show up right at the top of every sponsorship list, a small alphabetic advantage here. So Abaka AI is a global AI data company. Our mission is to become the top data partner for cutting-edge AI systems. We support R&D teams across generative AI, autonomous driving, and embodied AI with custom data services. We operate globally with offices in Silicon Valley, Paris, Singapore, and Tokyo, and we have worked with over 1,000 tech companies and research labs worldwide. This slide shows a few of the top universities, research labs, and enterprise clients we had the pleasure to collaborate with, from foundational research to real-world applications. And here at Abaka AI, we focus on the entire data processing workflow, from collection and cleaning to annotation. On top of that, we offer a large volume of production-ready, high-quality data sets that are directly useful for model training at scale. When it comes to data sets, especially those designed for multimodal training, our core focus is on image, video, text, and audio modalities. Beyond that, we are also actively developing data sets in areas like embodied AI and agent-based systems. Our goal is to provide high-quality, well-aligned data that helps unlock the next generation of generative and decision-making models. Also here in our company, we have built a global network of AI annotation centers through both in-house development and external partnerships. To ensure the highest standards, we will develop a dedicated training and evaluation system for our annotators, who are trained to be professionals that specialize in collecting, cleaning, and labeling complex multimodal data. With over 50,000 trained annotators across countries like Malaysia, Philippines, Nigeria, and Argentina, we are able to achieve remarkable annotation efficiency. And the most important thing is our strict quality control and data security protocols allow us to deliver reliable, high-quality data services to leading companies and research institutions around the world. And back to our main topic. We can see that Gen AI is moving super fast. We've seen impressive progress across image, video, and multimodal generation. Well, we can still see some shared challenges, things like visual artifacts, prompt misalignment, or character consistency issues in generated videos. Those problems are still quite common, as we can see we got some examples generated using different models like these days under the same prompts. I believe we share these challenges together, and many are rooted in the lack of large-scale, high-quality, and well-aligned training data. We would love to partner with Gen AI teams to close this data gap and help push the frontier forward. Next, I want to quickly walk through a few data sets we recently developed in collaboration with leading Gen AI teams, specifically designed to support training and in more specialized directions. Here is one example. This dataset was built for use cases like digital humans, multilingual dubbing, and AI presenters. We collected high frame rate facial videos with aligned audio and frame level expression labels. In labeling tasks like talking head generation, face-to-audio mapping, and lip sync modeling. Since we are collaborating with frontier teams in this field, we know what are the most critical parts for building great data sets. We put a strong emphasis on diversity, quality, and of course, the scale. Here is another example. We collected a wide range of camera motion trajectories along with continuous body motion data, giving models access to rich temporal dynamics and interaction patterns. This type of data helps generative models move beyond static shots in labeling them to simulate human-like perspective shifts, dynamic transitions, and more coherent, continuous character motion across scenes. Realistic human movement remains a key challenge in Gen AI video generation, and we hope this dataset can make a meaningful impact in that area. We are also closely following the shift from 2D to 3D generation, which is becoming increasingly important for world models and embodied AI. This dataset focuses on first-person game recordings captured with screen recordings, keyboard and mouse interaction logs, and GPU render outputs, supporting training for world models, 3D scene understanding, and also embodied agents. To support the 3D generation trend, we are also actively building datasets in several directions. 3D environment scenes in .usd format, 360-degree camera captures of real-world spaces, and high-fidelity 3D object scans across diverse categories, and so much more. We are still actively exploring the 3D data space, and would love to exchange ideas and insights with all of you guys. Apart from working with industries, Abaka AI also launches the 2077 AI community to support the construction of open source datasets for researchers and university labs. We would be more than happy to collaborate with your current researchers by providing data services, collection, cleaning, annotation, and ready-to-use datasets. That's what we can do. And our main focuses for this community are automobile AI, which is autonomous driving, generative AI, embodied AI, and some other more specific areas. We are pretty open to new opportunities as well, and we'll be more than happy to collaborate with cutting-edge research teams to explore more possibilities. Please feel free to reach out, and since it's the coffee break, I'm not gonna take too much time. If you have any questions, we'd love to grab a coffee and chat. Thank you so much, everyone.
Yeah, thanks Abaka AI for the presentation. We now have the poster presentations until 3:45 p.m. Then we can continue with the second session. Thank you.